Today we're going to look at factoring a GCF first and solving by factoring. So first let's talk about a greatest common factor. If we look at number 1, 5x squared plus 5x minus 10, we could do 5 times negative 10 is negative 50. We could look for two numbers that multiply to give us negative 50 and add up to 5. But that would make this problem a lot more difficult than it needs to be, and it wouldn't fully factor the problem anyway. So the first thing that you need to do is factor out a GCF. What do these two terms have in common? 5. We can divide all of these terms by 5. 5x squared divided by 5 is x squared. 5x divided by 5 is x. And negative 10 divided by 5 is negative 2. Now we can kind of ignore the 5. We can be like, oh, hey, 5, how you doing? You just chill there for a minute while I factor the other stuff, and we'll talk to you later. Now this x squared has a 1 in front of it, which means this is the same kind of factoring we did on the very first day. 1 times negative 2 is negative 2. We are looking for two numbers whose product is negative 2 and whose sum is this middle number, 1. Which pair of numbers does that? Negative 1 and 2. So, because our x value is 1, we don't have to do the factor by grouping. We can simply drop those numbers into the parentheses. X minus 1, x plus 2. Don't forget, we had the 5, so write your 5 in front of your factored form. Now the other thing we're going to be doing today is solving by factoring. So to make notes shorter today, I'm going to kind of weave all this into one problem. Let's say this problem originally said equals 0. That makes it an equation that can be solved. So at the end of our factored form, we are going to write equals 0. Now here's the great thing. You've already done this. This is a quadratic equation written in intercept form. What are the x-intercepts? Positive 1 and negative 2 are the x-intercepts. Now, why are these the x-intercepts? The x-intercepts happen where the y value is 0. So we've got 0 where the y would be. If we're multiplying three things together, we're multiplying 5, x minus 1, and x plus 2. We're multiplying those three things together and we're getting 0 as an answer. That means that one of those three things has to be 0. We can't make 5 equal 0 because it equals 5. But if we wanted to make x minus 1 equal 0, what would x have to be to make x minus 1 equal 0? Positive 1. So one of our solutions is positive 1. What would x have to be to make x plus 2 equal 0? Negative 2. So this is the same as finding your x-intercepts, but you're looking at when would each set of parentheses equal 0. So our solutions are x equals 1 and x equals negative 2. Now that problem didn't originally have the equal 0 on it, but that's the type of problems we're going to be seeing today. Equations where we have to factor, then using that equals 0, solve. So let's do number 2. Before we do anything, I'm going to change this so it says equals 0. So just from the start, this is a solve by factoring problem. First thing that you should always check from this point onward is, do the terms have anything in common that we could pull outside of the parentheses first? Looks like 4. 8y squared divided by 4 is 2y squared. Negative 28y divided by 4 is negative 7y. And negative 60 divided by 4 is negative 15. This time our a value is not 1. Our a value is 2. So I am going to say, oh, hey 4, how you doing right there? I'm just going to remember that you're there. You can chill, and we'll talk to you later. Then I'm going to mess with the 2y squared minus 7y minus 15. Because our a value is not 1, we have to multiply 2 times negative 15. That'd be negative 30. So we're looking for two numbers whose product is negative 30 and whose sum is negative 7. Does anyone know? 3 plus negative 10 is negative 7. 3 times negative 10 is negative 30. Because our a value is not 1, we have to do factor by grouping. So 2y squared plus 3y minus 10y. Almost screwed you guys up there. Minus 15. When we factor by grouping, we split these four terms into two groups. What do the first two terms have in common? It's just y. If you add the negative 10 first and the 3y second, then they would have 2y in common. But if you have the 3y first and the negative 10 second, then they only have y in common. The second two, I have negative 10y and negative 15. They have negative 5 in common, leaving us with 2y plus 3. So our factored form is y minus 5 times 2y plus 3. Don't forget that your 4 was chilling and waiting for you to have time for it. So that 4 goes in front, and we have equals 0 at the end. Now we have to solve. There is no way to make 4 equal to 0. But we can make y minus 5 equal 0. If y minus 5 equals 0, what would y be? So one of our solutions is 5. If 2y plus 3 needed to equal 0, sometimes you need to come over to the side and write down 2y plus 3 equals 0 and solve the equation. You would subtract 3 on both sides to get 2y equals negative 3. You would divide both sides by 2, and your y value is negative 3/2. Is there a way to do that faster? Notice it's a plus 3. Take the opposite of that, negative 3, and divide it by whatever's in front of the y. So if it's 2y plus 3, it's negative 3 over 2. But you'll get more used to that the more you do these problems. So our two solutions are y equals 5 and y equals negative 3/2. When these problems are already set up as equations, the first thing that you should do is check that it's written in standard form. You want the x squared term to be first and positive. You want the bx to be the next term and the c to be the next term and then equals 0. So you want one side equal to 0 and you want the other side in standard form. And a huge helpful hint is make sure your x squared term is positive. So 2x squared plus 2x. What do 2x squared and 2x have in common? 2x. 2x squared divided by 2x would be x. 2x divided by 2x is 1. And you have to write that plus 1. Remember, if you were to redistribute 2x times x, what the heck, computer? 2x times x equals 2x squared. 2x times 1 equals 2x. This is fully factored. This is the glorious thing when you only have two terms. It usually factors very, very easily. So 2x times x plus 1. Now we need to solve. Yep. For the first one, how can we make 2x equal 0? If x was 0. So one of our solutions is x equals 0. If we want x plus 1 to equal 0, what does x need to equal? Negative 1. Our two solutions are 0 and negative 1. On the next page, we are going to do number 7 today. We might look at number 6 tomorrow. Okay, number 7 is not written in standard form. Before you start solving, before you start factoring, you need to get it written in standard form. You need 0 on one side, you need standard form on the other side. And you want your, in this case, y squared term to be positive. So I'm going to subtract y squared from both sides. I'm also going to subtract y from both sides. That will give me equals 0 on the right side. On the left side, what is 2y squared minus y squared? 1y squared. Negative 6y minus y is negative 7y, and we have the minus 8. Now the nice thing about this is a factoring problem where a equals 1. So it's the simple factoring. Find the two pairs of numbers, throw them in the parentheses, and then solve. So try finishing this one on your own. So when we're factoring, we're looking for two numbers whose product is negative 8. Our a value is 1, so you can multiply 1 times negative 8, but you're still going to get negative 8. And the sum has to be our middle number, negative 7. That would be, seriously, 1 and negative 8. Now, we could factor by grouping, but the result of factor by grouping would still be y plus 1, y minus 8. Don't forget that this is an equation, so it's equals 0. What are our solutions? Negative 1 and positive 8.